kind of give everyone an idea of what we wanted to talk about this afternoon. There's a little more time compared to yesterday, and there's sort of two topics that we would like to address. One is any future interlaboratory comparisons, and this has come up a few times already in just the first day and a half. So some of the things to think about when we discuss this is what would the format look like? Are we looking at both isotopes? Where would we source the material for? You know, I know that Andrew Dixon's material was used for the previous study that was mentioned earlier. How many labs and which labs would be interested in participating, and at what frequency should we consider revisiting these types of intercomparisons? Something sort of Mashi mentioned, do we want to do a handful of samples? Do you want to talk about large scale intercomparisons, you know, every so often? And then the big question is also funding. So how much would any proposed interlaboratory comparison cost, and where we could consider the source of the funding to fund such a thing? The other topic, which was getting discussed a bit when I joined back on after the break, so I don't want to go into it or repeat too much, I guess, but it's a bit different. But building off of what Bob talked about earlier, we want to really define what we mean sort of by precision and the quality of the data that we're producing out of our laboratories. And so we need to talk about how we do that data processing and come towards some best practices and recommendations. And I was going to ask Rolf to give a few comments to kind of sort through some of the issues that came up yesterday regarding precision and what we sort of need, what kind of the gold standard we should be shooting for, and how we can work towards that.
Roberta warned me she was going to do this, so it's not really, it's not a sucker punch. So Roberta and I are the leads on the GoShip reoccupations of a subset of the WOS lines for C13 and for C14. And if you're not familiar with that, these are decadal reoccupations of cruises done in the 2000s and in the 1990s. So I'm going to use these weird units of per decade. The kind of C14 changes that we're seeing in data are about maybe plus 20 per mil for C14 at the bottom of the thermocline, and about minus 20 per mil at the sea surface, comparing the 2000s to the 2015s, for example. That means that we need to be measuring C14 to plus or minus 3 or 4 per mil to really characterize those changes. This is the penetration of the bomb signal through the bottom of the thermocline. But it also means that we need to have a consistent scale on which the C14 measurements are reported so that we can compare older data sets with the new ones. This has been a little bit easier for C14 and a little bit more complicated for C13. So we need to be precise to plus or minus 3, but we need to be accurate to a couple per mil as well for C14. For C13, the C13 Seuss effect, which is the temporal evolution of the C13 signal in the ocean. That signal is about 0.25 per mil per decade, my weird units. So 0.025 per mil per year. 0.25 per mil per decade at the sea surface is what you would expect for water that is equilibrating with respect to the atmospheric perturbation. We already have a lot of evidence that the sea surface is equilibrating. Where the really interesting science is happening is at the bottom of the thermocline, and those changes are only about 0.05 per mil in del C13 per decade. That means that in order to compare an old data set to a new data set, both data sets need to be reported to, or need to be precise to about, what is that? I think that's about 0.035 per mil in precision. But those two data sets also need to be on the same scale. Now, everybody reports relative to PDB, but when we look at one lab versus another, we see offsets at depth. We've been lucky in the past because the anthropogenic signal hasn't penetrated to the sea floor. So we can, if you're in the North Pacific, you can just take the offset between two labs, say deeper than 1,500 meters, and call that the offset and correct for that offset. We're not that lucky in the Atlantic Ocean anymore. We need to have data sets reported all on the same scale. either using working standards or reference materials. And it says my internet connection is totally unstable. I hope some of that made sense.
We got all of that, Rolf. That was great. I don't know if anyone has any quick questions for Rolf, but this is kind of, what we're swirling around for the discussions. So I'm grateful for you letting everyone know what we're shooting for. We have plenty of time, I think, for discussing this afternoon. I don't know if organizers, everyone, there's fewer people. I don't know if we want to discuss how much to divvy the group or if 4 still makes sense. But I would just propose we can discuss until 1:30 Eastern time and come back together and summarize.
I'm hoping there's more people here than we realize.
Could I ask, this is Wei-Ju, may I ask Rolf a quick question?
Sure.
So in the South Atlantic, for example, what is the safe depths you consider there shouldn't be, anthropogenic CO2 penetration? So if we do delta C13 compared with 10 years ago, earlier,
I know where you are. I know you're on the prime meridian, and I would say 36 degrees south, 1,500 meters and deeper would be a safe region for assessing an offset between 2 labs. I say that, but what I usually do is make a plot of either carbon tetrachloride or CFCs to make sure that the anthropogenic signal is at least not obvious in that depth range.
Okay, thank you.
Yeah, the CFCs are just so much more sensitive because you're going against a 0 background. It makes all the difference in the world. You see, I don't know, there may be a few places in the Northeast, deep Pacific where there's no CFC, but it's pretty much everywhere else.
Great, thank you.
To Roberta's points earlier about the laboratory comparisons, again, I think whenever we're discussing laboratory comparisons, we should weigh the energy required for that sort of a study. And I'm not saying that they're not valuable, but it's a lot harder to get to the desired endpoint by doing interlaboratory comparisons than it is by having a certified reference material. You get there very quickly with the CRM. You learn more about your system with the laboratory comparisons. Different goals.
Yeah, at present we have neither. So
yeah, and at present we have neither. That's right.
Except for C13, but
do we want to do 4 groups, or do you think 2 might work better? I'm showing 30 people. That would still be, that'd be 6 or 7.
Yeah, I think that I had 6 people in my group yesterday, and it was actually a nice, it worked nicely. People were comfortable speaking. But
I have 4 rooms set up now if we want to use those. And if you get into a room and I tried to mix people up a little bit, and people from the same groups, I tried to divide them up a little bit. But if you get into a group and you want to move elsewhere, feel free. The organizers are already grouped. They're already assigned to their rooms.
Roberta, were your points, that last page you showed, Roberta, is that going to be available to everyone sort of as a guideline for these?
Sorry, it's basically in the agenda, I think.
It's in the breakout notes as well.
Okay, thank you, Heather. Yeah.
And there's a link to that in the chat.
Okay.
Are you all set? Set to go?
right.
Is everyone back? Sorry, I wasn't.
Yes, our group is back.
Okay.
Whatever, we were 2, I think.
Do we want to just follow the model of yesterday and have each group kind of do a quick summary, if that's our minimal, and then we can have a larger group discussion. All right. I guess group 1. I can look at the form here. Someone from group 1 wants to.
Yeah, I took notes so I can do a quick summary. So first we talked about reporting uncertainties, and because we had Jason Waters from NIST, he shared with us a document that outlines how they do that, and a couple other standard guides that might be a good reference for people. And then we talked about interlaboratory comparisons. We talked about, once again, kind of how NIST was about that, some of the ways they do that, what it might look like if we did want to develop a certified reference material or a standard, and kind of the timeline that would take. Short answer, a long time, 7 to 8 years. And also what we might need funding for in terms of developing a standard, what the funding would be necessary for, what it would look like to get a standard. So essentially collecting a lot of seawater, which is kind of always an issue. So just more issues to tackle for the group. Some of the ultimate goals of developing a standard and how accuracy is still going to be important even while we develop something that we want to be able to compare between groups and between labs, and just some things to consider. And then we got ahead of ourselves and talked about standards again for a second, but we'll also talk about that tomorrow. So that was it.
Thanks. Does anyone have anything to add or have any questions for group 1? All right, group 2. I guess if we go through this kind of quickly, then we can discuss as a larger group, I guess. Is that where we're heading?
Bob, did you want to summarize or do you want me to go over?
If you'd go over the notes, I think it'd probably be more accurate.
Sure. So we got off on a bit of a tangent about databases. There was some passionate database people in our group. But for interlab comparisons, not many of us have participated in these kind of exercises, but there seems to be a strong willingness to do so. I think the agreement was any lab would be happy to participate in such a comparison and perhaps commit to dozens of free samples to measure. We had a discussion on material format. So would it be more useful to do water or gas samples? Kalina thought perhaps having a water standard would be the best. Solid is not the most appropriate material. It needs to be dissolved. And each lab has their own way to do this, which can introduce some bias. So a true water standard dissolved carbonate would be the best. Talked a little bit about mercuric chloride and if that might be an issue for comparisons. Some labs don't accept that. So some difficulties there. And for reporting uncertainties, we kind of ran out of time on this point. But Bob made a note that it's important not to underestimate the true error. And that was it.
Thanks. Does anyone have anything to add from that group or any questions for group 2? All right, so group 3. Katie, do you mind giving a quick summary?
I don't mind at all. So we had representatives from NOSAMS, NSF, and NIST in our group, as well as data collectors and users. And we had hit on the same points as group 2 as far as seawater standard being desired because of for the same reasons. And other main points, we had some discussion about the format of future interlaboratory comparisons, a recommendation of perhaps a small collaborative team leading a proposal to NSF chemical oceanography with justification related to improving measurements which will serve the whole community. We discussed kind of the timing, whether a standard certified or not certified by NIST, but with a value reference material established, is whether that reference material needs to be established before an interlaboratory comparison, or if it's okay, similar to the Cheng et al. 2019 study, to have those occurring in tandem, the development of the material, known value, and the different labs preparing it. And one other note that I'll highlight is there was a desire for a step-by-step best practices for quality control written down guide or paper from Bob Key, so that all users process and report in the same way. The presentation was wonderful, but there was even more details that were desired. So, anyone else want to add anything else?
Thanks, Katie.
Sure.
If anyone has any questions, then we can have the last group summarize.
Hi. So our group talked mostly about reference materials. We spent a lot of time discussing the merits of powder and liquid references. The bottom line is that groups want a reference material they can use that's free of any variability due to sample stability issues or any variability in methods of making up the standard. So solids are nice because you can create a lot of it and it can last for a long time. It just needs to have a really good method for making up the liquid that's repeatable and reproducible across labs. We talked a little bit about the idea of a reference material from a cruise, from Niskin's sampling, having a couple groups sample by the different methods that they've been using to sample, and then distributing those to groups as they, by the sample type they wish, whether in bags or bottles or whatnot. A lot of this is repeats of what other groups have talked about. We talked a little bit with the NIST people in our group about the potential for them to make a solid or liquid reference. And the 13C people in our group especially thought it would be great to have a 3 references across a range of values so it can be used as a normalization standard. We talked a little bit about uncertainties, but I don't think there's anything new there compared to what the other groups have talked about.
Thanks, Brett. Does anybody have anything to add or any questions for group 4? We have about 40 minutes left. I don't know if someone can stop me, or organizers or anyone, if we had plans for this time, but I think we could maybe have a broader discussion about these topics, or if anyone has a targeted topic that we want to specifically address. I know we're all kind of dancing around the same ideas, which is great. That's what we're supposed to be doing.
I think, go ahead, Ann.
One thing I was going to say, of course, everyone wants a liquid standard, which is going to limit its stability. But there is an advantage to having a gas and a liquid standard. If you look back at the comparison that was done in 2000, the labs were far better aligned on the gas standard than they were on the water standard. And you get information from analyzing both a gas and the gas is easier to produce than the liquid one. She says that naively. So.
I thought the idea we just heard of, and I noticed I immediately scrolled through the list and I didn't see that. I don't think Rick is still on the call, but I wouldn't be surprised if NOAA couldn't arrange on one of their cruises that did get off the coast and out into deep water, could not dedicate a cast to producing replicate analysis for C13, C14, and I dare say they would take some of the samples themselves for total CO2, alkalinity, and pH measurements. But I don't know that that's ever been done before with any decent number of samples, and it would be the best true world comparison that I can think of. The downside is I'm sure they would poison it with mercury, so that could be a problem for a few labs if they really didn't accept mercury poison samples. But and I'm not saying that I disagree with Ann, because I don't. I think both types of samples are extremely useful. But there's a lot of air at sea as well.
So some labs just absolutely refuse to take a seawater sample poisoned with mercuric chloride. Is that correct? Because I have all these documents that were sent to, which go with samples that are going to be shipped from foreign countries to the US, stating how little mercury is in each water sample and how you could basically drink it and the salt water would be more of a problem than the mercury. But
oh yeah, the salt would kill you a lot faster. I don't know that it's just been mentioned a few times. It's the only reason I mentioned it.
Yeah,
It's
no.
it's an
Let's not drink
incredibly
any of
small
the
amount.
seawater samples, and when we'll start there as for safety first.
Well, it's
Sorry,
yeah,
I
it's,
took the
Good,
card.
I didn't recommend this.
yeah, it's gotten a bit ridiculous. I've had captains who out on the ships who were just ridiculous about the mercury. I mean, okay, yeah, it's mercury. It's not good for you. Don't drink it.
Yeah.
And other than that, there's just not much mercury in each sample. That's for sure.
Well, and certainly Andrew's standard is poison with mercuric chloride. Is that correct? So the carbon
That's
community
correct.
has to be able to.
Oh yeah, and his, I've forgotten how long he. I won't say warranties, but his samples are good for months, and I think probably a year, something like that, with a couple of oddball exceptions. He had in the 20 years he's been doing that, he had a couple of batches that had some mercury resistant bug in it that threw those batches of CRM off, but it's rare.
And to your point about the gas, and this may also be naive, but is there not already certified gas standards with isotope values, or no? I mean, if you're really just,
Well,
if you're
I think
not
if you're
concerned
getting
about the extraction method from seawater, I mean, don't
I
these
think it
exist?
gives you, yes, but not lab, a lot of labs don't measure gas standards all the time. So no, it's not necessary, but it gives you two data points on how a lab is working. I can argue it either way.
Well, I just mean that you wouldn't have to create a new material, that there would be one out there in the international standards community that already exists. That's what I don't know.
Is there?
Your two certified values.
There used to be, but I don't know if suddenly if there were a run on it, if it would be a problem.
So there's three at NIST. So there's 85, 62, 63, and 64, and they're pure CO2s of different isotopic compositions. They're a little bit clumsy, I think, for a lot of labs in that, I mean, they were made in the mid 90s. The volume of gas, I think, is probably a bit larger than people use these days. And they're also just very, very long. They're in these glass tubes meant to be put in a tube cracker, and they're just much longer than any tube cracker I've ever seen. But so anyway, if there's feedback from the community about those materials, in terms of quantity of gas or, length of glass tube, I'd love to hear it. Anyway.
People will complain about everything, but most people, if you give them a sample with gas and say, I need a measurement, will figure out a way in their lab to crack it open. People agree?
That being said, it is the best approach to treat your standards, just like your samples. So if they go through the same process, they are being extracted, and then they're being acidified, and then they're being measured. The value that you get is well, reflects your whole system, as opposed to just running a gas. You will get better data for sure, because you are excluding all the prep system. So
yeah, that is actually the point, is to see how much difference and whether the shifts are the same with, anyway. The idea is to have something that's easy and something that's hard and get the data. It's just an idea.
Sorry, the gas will tell you about the measurement system, and the water samples would tell you about everything. And the difference in the two would tell you which side needs work.
So just for additional information from NIST, I just looked the 3 reference materials that Rebecca Kraft, who's in the group that I lead at NIST, that she mentioned, have decent supplies left. The stocks are not, they're not close to being out of stock. On the other hand, we do have sales restrictions on them to try to preserve them so they last longer. So I don't know how that would impact an ILS if you know, if we would need to lift the sales restriction for a period of time or whatever, but just letting you know, since those were brought up.
Thanks, Mike. I know Rolf and I were talking yesterday, is Rolf still on here, about the feasibility of getting sort of a cast, what you mentioned, Bob, or what someone mentioned earlier, and talking about, and I guess someone else can comment, and Rolf can comment if he wants, but it sounded like with enough planning, it should be possible. We can't do it obviously in any sort of currently planned cruises. That's going to be very tough to get that kind of water, but if we look further in the future, that it shouldn't be too difficult to arrange something like that, or figure it into the planning.
Yeah, I think you're right. Well, I would slice that just a little bit finer. I think it would be difficult to get it on a currently planned, or future for that matter, wouldn't make any difference. Ghost ship cruise. There are just too many people that want the water, and there's too much going on those cruises. But there are a lot of cruises that go out that could collect the samples. And ideally, the reason that I would pick a NOAA cruise is because whether we go East Coast or West Coast, there's a good carbon group at PMEL. There's a good carbon group at AOML. They both have ships. They both go out. They can both run CTDs. And just my gut feel is there would be more opportunity if we wanted to ask them to do one additional cast, have them measure DIC alkalinity, total CO2 alkalinity, temperature, salinity, oxygen, and you might as well measure nutrients. It's only a few milliliters to do that. Basically do a full vanilla suite of measurements on the samples, and then take all the rest of the bottles, all the rest of the water that was in each bottle, and split it up as samples to distribute to various labs for a comparison. It would be roughly 4 hours. Well, it could be as much as 4 hours of ship time. So that would be the sort of request in terms of real money. Ship's about say $50,000 a day, so you can figure out what 4 hours comes to. And we literally could pay for that if we had any sort of a C14, C13 comparison. We could just include that in the budget. There's one, maybe have a half a ship day.
Rolf also mentioned a Hawaii Ocean Time Series cruise. There's also, this is, Bob, I know you're very against this, but just throwing out to the community. There's a station on Hawaii on the Big Island that's 900 meters that serves water from a tap. So it's not deep, but it's available, very readily available.
You could certainly get a ton of water, but if you got it on Tuesday, would it be the same on Wednesday?
I don't know, but just get it all on Tuesday, and then
Yes.
I mean, it's the same as your cast, relatively.
Yeah.
You do cast, but it's an option also.
I mean, there's the Hawaii. Everyone wants to go to Hawaii. Bermuda also has a easy access to deep water.
Who is Nick Bates still at?
Yep.
Oh, yeah, Nick would be a friend. Yeah, we could get Nick to help us out, I'm sure. And he's very strongly tied to the carbon community and has been for decades. I mean, possibilities like that exist. It's just my leaning would be to not let that in any way hinder the development of a CRM.
No,
I think the CRM is more important than a laboratory comparison. And I'm not saying don't do both, but if you only gave me enough time and money to do one, it would be, I'd put it all in CRM development. Because they really have, and that's because of where my highest priorities lie. And I'm sure some of the people in the group have quite different priorities than what mine are. One of the groups had a fair amount to say about CRM development and so forth in their discussions. Would anyone be willing to summarize that with a bit more detail for the whole group? We didn't talk about it at all.
I actually cut off conversation because I said we're talking about it tomorrow.
Well, and perhaps that should be, yeah, what we do is just talk about it tomorrow. Yeah, that's probably a better idea.
Because we will have Andrew Dixon tomorrow, and he will
yes,
have a lot to say about it too. So,
yep, he can certainly give us the history and better than anyone ever could.
I will say something just to interject what came up in our group, and Mike was in our group, and we were talking about a reference material from NIST, but then also the interlab comparison, and something that maybe everyone else was thinking about, but he said they do this at NIST often, would be to do these things kind of simultaneously. So, especially if we're not going for a certified value, if we're going to just an assigned value, distribute what would be our reference material, use the interlab comparison as a way to establish multiple values or really narrow in on that value, determine that value. And then you're kind of doing both at the same time.
Was that one of the poll questions? I doubt it, but what would be the consensus? Maybe that's something we should aim for tomorrow, is to get a consensus as to what would be the best way to assign a value to a CRM. I mean, with the CO2 community, we had a laboratory that all of the people in the US at the time thought was the gold standard. And we simply took their number as being right. And it was manometric measurement methods. But I don't think such exists with C13 or C14. Maybe I'm wrong about that, but I think that's certainly one of the difficult questions we would want to answer early on, is how do we assign the value to the reference material?
Oh, actually, Bob, if the material is a powder,
it's not going to be a powder. It'll be a water.
Well, then if it's a water, yes, it's more difficult. That's for sure.
But can we use NIST standard yesterday? That I forgot the name, that's replaced the NBS 19. And it's powder, but you could use, we can prepare acidic water, diluted HCl and bubble with nitrogen or helium, and then just drop the powder there and use that as standard. Why that is a problem?
Well, at
You
least with
develop a procedure to do that.
well with the DIC in seawater, that's the way it was done up until WOS. And what we found was that while you should be able to take some powder and drop it in liquid and dissolve it and measure it, that's simply not possible. You would think it would be. It's about as easy as it can be. But that is where the 20 micromole per kilogram offset from lab to lab came from, was all sorts of differences.
Yeah, I would think actually for DIC, that's very hard, but for delta 13C, that's actually easier because you don't need the absolute concentration. If you could prevent air contamination, and that shouldn't. I would love to try that actually.
Yeah, if I might, this is Mike Winchester from NIST again. I don't know about what you're suggesting. I do know that our history at NIST of doing interlab studies is that even things that seem like it should be falling off a log are not like falling off a log
at all.
That's the problem that I think Bob is trying to get at. We've done international comparisons with other NISTs, NISTs around the world, the National Metrology Institutes. Very simple measurements, and the data come back all over the place.
Yep.
And I think that's why Bob keeps saying this, and why the community as a whole, and yesterday and today, seems to be leaning toward having an actual seawater reference material, because it takes the steps, which are variables in the measurement process, or the preparation of the standard, I should say, the calibration material, takes that variability out of it. And I've never worked in this particular area, so I can't say from experience with oceanography with making these standards for this, but what Bob is saying is very consistent with my 30 years at NIST. Very consistent.
Yeah, that's exactly what I'm saying. Yeah, it's just simply beyond the state of the art to do it.
Another approach maybe, have the NOAA's atmospheric lab to supply gas standard. That could be another option.
Well, again, a gas, then you're measuring a gas. You're not measuring a sample that looks anything like what your samples look like. I mean, the only way you get there is to have something that looks exactly like a sample.
Actually, the CIM 195, we just measured that value. We got a 0.78 is very close to what Doug Wallace group with that 58, a very early one. What it was, I forgot what is the number, but that's the one they published in that Chin 2019 paper. I'm surprised. So apparently the procedure Dixon produced these CIM generate somehow very similar result. Although we use the various batch, they are somewhat different.
Well, like I said, by going to something like a CRM, the DIC error went from about 20 down to less than 4. It took a bit longer, but we got a similar change in alkalinity. And right now, the global community is going through the same sort of change in nutrients, where even in mid-Clavar, there was the Japanese and the US were both producing extremely precise data, but there was a 2% offset. 2%. in nutrients. And how long, how many, what, 100 and something years we've been measuring nutrients, and making standards for nutrients is pretty much the procedure you were describing. You know, you mix some stuff up, but even with that, the best labs around the world were not able to do it and get the same number until, in the case of the nutrients, the Japanese started producing certified reference material. Well, what they call certified reference materials.
So Bob, oh,
yes,
go ahead, Ann.
Well, this was just a general question. One of the things I have trouble with in thinking about production of a reference material or a laboratory comparison experiment is how many people want to be a part of it. I'm looking at the poll that we asked everyone to fill out for tomorrow, and only 14 people have filled it out. Does that mean there are only 14 people on this in this group that actually make the measurements? Who are we missing?
Because, and that's true, and especially for radiocarbon, I think we are even fewer.
Yes, yes, but
so for radiocarbon, it wouldn't actually be that difficult to do something similar to what Chen did. Maybe, but with real samples. I don't know.
so, I mean, if you're talking a small number of not too many people, it gets a lot easier to develop both the reference material and the comparison experiment.
well, I think that's the other thing we need to walk away from this workshop with is a lab count for each isotope individually. How many do 13? How many do 14?
And what method?
Beg your pardon?
And what methods being used for those measurements?
Irrespective of method, just a simple count of the number of labs that make it, and then how they do it would be we could certainly subset it.
And we must have forgotten some people, so we should probably figure out a way to find out who has not been invited here and should be a part of a study. That's a hard one to get, but.
So, and that's in your email, right? You said a form. I need to fill that out.
Maybe we can ask May or Heather to put it in the chat, the link to it in the chat. So
I will add it in a moment.
Okay, great, thank you.
Thank you.
So just hang on.
Is Arizona?
Sorry, go ahead, Bob.
Oh, I was just going to ask if Arizona still made, or if Arizona made any water measurements.
Arizona has changed so much, I don't know the answer to that really. They did focus on groundwater, so.
Oh, just on groundwater, okay.
They have some ongoing issues, I think, with their accelerator that I'm not sure what that means for any of their measurements at this moment. But.
Okay. Go ahead, Mike. You had a question? Or
yeah, well, I was just I think Ann wanted to not spend too much time talking about reference materials.
Oh, no. This is.
I'll say from the perspective of assigning values, 14 labs is not really a bad number of labs, so long as they're not just all over the place with their values. If they come back somewhat consistently, it's not such a small number. As we have the statistical expertise on campus at NIST to deal with that. Whether or not it results in a value that is small with a small enough uncertainty to satisfy the community, that's a different question, and I don't know. The carbon-14 maybe is a different problem. As we were talking in Roberta's group in the breakout that there might not be more than 5 labs that could make that measurement. So that might be a different issue altogether. And then, finally, one other comment, going back to, I think it was Amanda that said this, but, it's always good for trueness. It's always good to have different methods making the measurements, right? So it's better if you have, a few cavity ring downs and a few IRMSs, but not just all of one or the other. Okay. Now, I wonder also, is the University of Utah ever a part of this discussion? Now, I haven't looked in a long time. Rebecca Kraft is also on the call. Rebecca, you might know more, but at one time they had a pretty active precipitation isotope laboratory effort. Rebecca, do you know more about that? If I can just ask you.
So they do. I mean, both IAEA and University of Utah do isotopes in precipitation, but they aren't like, they may venture occasionally into the carbon community, but I don't think they are doing as much in the water and carbon community. It's mostly oxygen and hydrogen isotopes, particularly for provenancing different types of things.
All right. Thanks for answering my question.
So Ralph, why don't you just ask Bob the question?
My internet is in and out, and somebody kicked me out of the meeting. But so it seems to be working.
Yeah, we're getting you.
I can hear you fine. Yep.
So you're saying that during the WOS era, the DIC measurement groups prepared working standards from solid carbonates, and that their resultant values differed by about 20 micromolar. Is that about right? Is that what you're saying?
That would be a bit, that would be on the large end, but certainly 10 was not uncommon at all. And I'm talking about systematic bias, not random.
Right. And so that means that 0.5% of the total carbon is either unaccounted for, or you've got some extra carbon from headspace exchange. In our breakout group, we had a long discussion about whether one could develop an absolute standard methodology for generating a synthetic water sample or a synthetic seawater sample from a powdered bicarbonate. I actually don't know the answer to that question, but that would allow for a range of C13 values. One thing in our breakout group was that it was noted that people doing del C13 in freshwater encounter a much larger range of values than we do in the ocean.
That's right. And they don't have to have the sort of precision that, I mean, it's always nice to have infinite precision, but in reality, if you've got that sort of range, you don't need the precision. God, we used to call them shinks. You take the natural range and divide by the measurement precision, and you've got an estimate of the power of the measurement. And the power of the measurement pretty much moves across the fields. That's the accuracy or precision you need depends on how big the range is in the area you're measuring. So I would say if you start talking about groundwater, you're talking about a completely different set of rules.
Yeah. My perspective from looking at isotopic changes in the ocean, now we're talking blue water oceanography.
Correct.
My perspective on that is quite different probably from a freshwater scientist. I have statistical ways of dealing with imprecision in the measurement, but I don't have a solid way of dealing with inaccuracy in the measurement. That is to say, if one station or one cruise section is on a slightly different calibration scale than another one. I don't have any more very good ways of dealing with that.
Well, there are ways, but you're forced to go to the sorts of calibration techniques that we use in GLODAP, or that Brendan Carter came up with his LIRE techniques.
Right.
Things like, you can do things like that, but again, it's they're certainly, you use them if you have to, but you'd rather have something better. And I think we're completely capable of developing a reference material for open ocean, blue water, full water column, any sort of, if the water is greater than 200 meters deep, then you take the total range of C13 and C14 you'd find anywhere in the ocean, and we can develop a CRM that'll work for that range and be, sufficiently accurate and precise. It's never been done because people tended to look at small scale problems, and now we're really, in the last 20 years, we've been faced with looking at global scale problems. And you've got to have it if you're going to do global scale oceanography, biogeochemistry, environmental science, climate change, whatever name you want to put on it. We've got to have everybody's data, and you've got to be able to put them together without creating problems, because nobody can make all the measurements. It's just too big a problem. Sort of like fighting COVID, we've got to get together on it.
In our breakout session, there was a thought that maybe we don't really need to do an interlaboratory comparison at this point, because one was just done, and NOSAM's got a split of that sample and contributed sort of after the fact. Kalina presented that. So on the topic of interlaboratory intercomparisons, it might be most important to pursue that for C14, which sounds like it's pretty easy because there's 6 labs or whatever.
Well, I certainly think we could get enough, say, 10 replicates or 10 samples with 6 of each, and distribute those to the labs with almost no trouble at all. And we could draft Wanenkoff to delegate that and get it taken care of pretty quickly. I think either that, or or Nick Bates, or the folks out at, well, there's plenty of people. I think if the group wants to do that, we can make it happen. And with plenty big enough samples, that would require, I would think, a small proposal that included, it could have one PI with 5 co-PIs, or there's a lot of different ways to organize it, but and just do it. So you could have the money a year from today. You could have the results published 2 years from today. And that would give us the state of the art as we are right now for C14 and presumably C13 for those 5 or 6 labs. Or for that matter, that we could also, let's see, say if you use 12-liter bottle on the Rosette, there'd be plenty of water to get smaller samples for C13 analysis. If someone's got a go to see 50 milliliter bottle for C13, there's no reason you couldn't fill up a dozen of those to send to the other groups.
On one of my recent cruises, there's another group did a comparison between, they just collected a ton of DIC samples from the same Niskin, and they saw that DIC actually changed throughout one Niskin. So I don't know how you standardize against that.
It shouldn't. I mean, I have looked at enough Niskin bottles to know that that can happen on the inside of a Niskin bottle, but if it's a deep water sample and it tripped properly, that should never happen unless you're getting significant air contamination. You know, if you ran if it were a 12-liter Niskin and you got down to 1 liter left or something, then I can imagine that, and you were doing full 4-digit precision on your measurements.
What are you saying is the significant variation? What's your definition of how big a variation are you talking about, Amanda?
Oh, sorry. So I didn't actually measure them. I was just talking with someone who did it on the cruise I was on, and they said that there was a measurable difference between the first sample and like the last sample that they collected from it. I can give you the name of the person who did it.
Were they measuring?
I mean, I'd like to see the data.
I didn't do it, so I don't want to say like.
No. I'm just going to say that we have collected a lot of samples from, you know, for our internal. Excuse me. NOSAMS has collected a lot of samples for an internal standard, and there, as long as you've got good deep water that doesn't have a lot of particulate matter in it, you should be able to get reproducible. We have had questions when we tried to collect so much water. There were a lot of different Niskins in use or a different cast. And when there's different casts, yes, you'll get a difference. But however, we used to use Buzzards Bay seawater very early on. And we filtered it because there was so much particulate matter, and all that made it very difficult to get a precise, which is why we started using the open ocean water.
Well,
I don't know all the sorry.
Go.
Isn't that an excellent question though? Because you have a 12-liter Niskin, and each sample takes maybe 1.5 liters. So you can get 5 samples out of that Niskin, which might take 20 minutes. And we're talking about an abyssal sample. So it's super saturated with respect to the atmosphere. So during that 20 minutes, that Niskin bottle is degassing, and it's losing a light form of CO2. It's losing CO2 gas itself. And the bicarbonate and carbonates aren't re-equilibrating. I think that's what you're talking about, Amanda. So a coulometer would pick up a change in concentration, a decrease in concentration over that 20 minutes. And we have to be sensitive to whether or not that CO2 loss multiplied by the -8 per mil that CO2 is will impact. I haven't done the calculation, but it might be enough to impact the del C13 of those 5. You might have a trend across those 5 samples from one Niskin.
If you're measuring pH or PCO2 or PCO2, I would guess. Well, we know you do run a chance of seeing it. Well,
I actually think we need to know more about this collection before we start going too far on it. So
I just want to mention that there might be a difference.
I mean, I don't believe we see that with our internal standards and NOSAMS. And also, Rob, if you collect less than 500 mils of water, you'll be able to take a lot more samples, and you'll be able to see a trend if this is happening. We haven't seen that with our 3,000 meter water.
Well, we can also get around it by using a 30-liter Niskin instead of a 12.
So
there's lots of 30-liter bottles around.
I mean, A13.5 is happening this winter. I could beg the chief scientist to to allow us to sample a Niskin right away, fresh Niskin, and then allow us to take a Niskin that's half sampled and see if the del C13 of those 2 samples differ. I mean, that's not a crazy first step. Doesn't cost much other than I got to be nice to the chief scientist.
You don't even need his permission because we're collecting C14 on that cruise anyway. So we've got a ton of bottles out there. And
well, you do need to get permission to go ahead of oxygen.
Yes, but you're not anywhere near halfway down the bottle when oxygen comes out.
Yeah.
Yeah, as long as you pick a cruise where not everyone is measuring, then there's plenty of water to get an extra sample out. It's only the first, the high profile stations where you run out of samples, run out of water, or run low on water.
I have a related question to the organizer. Do you worry about, for Delta C13, do you worry about airborne CO2 contamination because all your bottle collector for gold shipper or repeat hydrography has a head space there? And anyway, maybe Amanda could tell you what we did a comparison during the Waikoa cruise. But Doug Wallace's lab was doing all these painstaking procedure to prevent airborne CO2. Bob?
No, as far as I know, no one takes any special precautions for that. Now the carbon samples do go, gosh, I don't even remember it's been 2010 was the last time I went out on one of those cruises. So I don't even know what the current sampling order is, but I know the thought is that the most sensitive samples are always collected first. And of course, this is the same on the cruises you go out on. You start out with CFCs are about the first thing to sample because they have the fastest equilibration time and are the most sensitive, one of the most sensitive measurements.
Sorry, Bob, we're over time, and I'm sure this is. Can we take this offline or do this one tomorrow?
Yeah, I think let's go. Let's pick it up tomorrow.
Thanks. I'm sorry to cut you off. It's getting late for people who aren't in our time zone. Can we spin the wheel, Heather, or is that a daily thing, or was that a? Sorry.
Oh, we got to have a wheel spin.
I'm sorry, Bob. I just everyone can wake up for one more minute and then.
Is she here?
Xiaomei, is Xiaomei here?
I saw her this morning, but I don't know if she's
still here. Speak up, Xiaomei, or you're. I don't see her in the list. So.
And we're down to 29 of us.
All right, spinning again.
One more chance. You.
I don't think I've seen this person at all, have I?
No, I haven't either.
I haven't.
Okay, here we go again.
2 minutes.
Oh.
Michael's here.
Mike's here. All right, we have a winner.
We have a winner.
Are you allowed to accept it by NIST rule?
Yeah. This is fine.
Thanks, everyone.
Send us your address, Mike.
Sorry.
Okay, I will. Thank you.
Thanks for all the discussion. Sorry that things ran a little bit long, but hopefully we'll see you all tomorrow, same time, and we'll get into these CRMs that we've been dancing around the whole time and try to make some real plans for moving forward. So look forward to that. Thank you all.
Thanks, Roberta.
Thanks a lot.
Thank you.
Heather. Thanks everyone for coming.
Yeah.